Complex systems do not fail instantly. Long before collapse becomes visible, stability begins to erode internally through oscillations, delayed feedback, and uncontrolled amplification of small disturbances. A star collapses when pressure regulation fails. A bridge collapses when resonance overcomes damping. A human body dies when homeostatic control can no longer stabilize internal chemistry. In physics, survival is not passive. It is continuous correction against instability. Most people think stability means stillness. Physics says the opposite. Even apparently motionless systems are constantly fluctuating. Atoms vibrate through thermal motion. Structures flex microscopically under stress. Atmospheres redistribute energy through turbulent flow. A stable system is not one without disturbance. It is one in which disturbances fail to grow uncontrollably. This is known as dynamic equilibrium, opposing forces continuously interacting while the overall structure remains functional. Without mechanisms that absorb or suppress instability, complex systems rapidly collapse. Stars survive through hydrostatic equilibrium. Gravity compresses stellar matter inward, while nuclear fusion generates outward radiation pressure. But stellar stability does not emerge from these forces simply matching. It emerges from feedback regulation. If fusion rates increase excessively, the star expands, reducing core density and slowing fusion reactions. If fusion weakens, gravitational contraction increases temperature and restores fusion pressure. The star continuously corrects itself automatically through thermodynamic feedback. A stable star is therefore not static matter. It is a self-regulating plasma system, permanently resisting collapse. The same principle exists inside your body. Human survival depends on homeostasis. Layered feedback systems that regulate temperature, oxygen, glucose, pH, and blood pressure within extremely narrow survival limits. When temperature rises, vasodilation and sweating increase heat dissipation. When glucose falls, hormonal signals mobilize stored energy. When oxygen drops, breathing and circulation adjust automatically. Your body survives because it constantly detects deviation and corrects it before instability becomes catastrophic. Life is not chemically stable by default. It is actively stabilized every second. Modern engineering relies on the same physics. Aircraft continuously correct turbulence during flight. Electrical grids dynamically redistribute load to prevent cascading failure. Skyscrapers use tuned mass dampers to suppress resonant oscillations caused by wind and earthquakes. Without damping and feedback control, small disturbances can amplify into runaway instability. The collapse of the Tacoma Narrows Bridge demonstrated this dramatically. Ordinary winds synchronized with structural resonance until the entire system destroyed itself. Physics shows us that order is never automatic. Every stable system consumes energy to resist collapse. Every complex structure survives through regulation, feedback, and correction. Yet somehow, the universe itself emerged with laws capable of sustaining that order across stars, planets, life, matter itself. So perhaps the deepest question is not how systems remain stable, but why reality permits stability at all.